Hi, today we have a problem that's in two parts. First, we want to solve a problem involving a quadratic equation. And once we obtain the result from there, we'll use that result to help us prove a secondary result. So first of all, here's what we want to do. We have an equation right here, and we want to show that all the real values of x that satisfy that equation lie between these two values, between 1 over 198 and 197.99494949, etc. So where can we start with this? Well, this looks like a quadratic equation, right? Let's just unwind it a little bit. We'll unravel it into a more familiar form. So if we cross multiply and then rearrange everything into standard form, we obtain this result here. So how do we solve a quadratic equation like this? Well, it doesn't factor. You can try. So let's use the quadratic formula. We get negative b plus or minus the square root of this quantity squared minus 4 times 1 times 1, which is 4. And we divide this all by 2 times 1, which is 2. Well, this squared minus 4 is 39,200. But that radical reduces. It reduces to 140 square root 2. And now we can simplify this one more time. We get 198 divided by 2 and 140 divided by 2 is 99 plus or minus 70 times the square root of 2. Well, what do we do from here? Well, we know from quadratics that we can take the sum of roots to be alpha plus beta equals negative b over a. So here alpha and beta are roots of the quadratic equation. B and a are the coefficients of our quadratic equation, b being negative 198 and a being 1. Well, if we plug in our numbers, negative 198 is 198. And then we divide by a, which is 1, so we're left with 198. What this gives us is two relationships. First, we can say that alpha equals 198 minus beta. Secondly, we can say that beta equals 198 minus alpha. Okay, so now what? Well, since alpha and beta are roots of our quadratic equation, they satisfy the equation. So what we can do here then is say that from our quadratic equation right here in its original form, alpha satisfies that. And beta satisfies that. If we look at this a little more closely, just by shuffling this quantity up here, we get this. And likewise over here, we obtain that. But 1 plus some quantity is greater than 1. So a quantity greater than 1 divided by 198 is going to be greater than 1 over 198. And with the same argument over here, this will be greater than 1 over 198. So at this stage, we've obtained half of our proof that alpha and beta are both greater than 1 over 198. These values, these roots which satisfy our quadratic equation, are greater than 1 over 198. And so this is the lower bound of what we're looking for in our proof. Okay, well let's continue and find out how to get this upper bound. So let's take a new board. Okay, here we are now back at our new board. To summarize what we had before, the roots of our quadratic equation, alpha and beta, are greater than 1 over 198. The solution to our quadratic equation was x equals 99 plus or minus 70 times the root of 2. And we had this relationship between alpha and beta, this one and this one. Well, at this stage, we now know that alpha is greater than 1 over 198. So this is greater than 1 over 198. And beta is greater than 1 over 198. But if that's the case, then what we obtain is the following. Alpha has to be less than 198 minus 1 over 198. Why? Well, here alpha is 198 minus this quantity, and this is something bigger than 1 over 198. So if you subtract some number off of 198 that's bigger than this, you end up with a smaller answer compared to subtracting off 1 over 198 from 198. By the same reasoning, beta is also less than 198 minus 1 over 98. 1 over 198. But this and this are each precisely, if you use a calculator, this value right here. And so now we see that we have obtained the second part of our proof above. We have alpha and beta, the values that satisfy our quadratic equation, being greater than 1 over 198, and alpha and beta each being less than 197.99494949, etc. Okay, good. So the values of x that satisfy this equation, yes, they are between this value and this value. They are greater than this, but less than this. Good, so that part of the proof is done. Well, now we want to take what we have to help us prove the second part of our proof. Namely, we want to show that root of 2 is smaller than this value right here. Well, what can we do? Well, we know from earlier that the solution to our quadratic equation was x equals 99 plus or minus 70 the root of 2. Well, for example, alpha is a solution to that, or alpha satisfies this. So what we can say now is alpha, that's one of our values, equals 99 plus 70 times the root of 2. Okay, let's rearrange that for the square root of 2. But alpha is less than 197.99494949, etc. So what we have here is that the root of 2 has to be less than alpha minus 99 divided by 70. But what does this work out to be? This subtract this is simply Sorry. And when we divide by 70, what does this work out to be? Well, in fact, it works out to be 1.4142135642. So indeed, we can say that the square root of 2 is less than this value right here. And now that completes the second part of the proof. So we're done. We've completed part 1 and we've completed part 2. Hope you enjoyed. Thanks for watching.